Okay, got back to this slide. See if I can adjust things here. No, I don't want to do that. So, again, these center pivot irrigation systems tap into groundwater, and that apparatus rotates around a field. Uh, okay, so again, these systems irrigate large patches of ground and take water out of the ground. Um, In much of the country, it's largely surface water that's used. You can see around the country, this is the amount of water being taken from surface waters. You can see California takes a lot out. Tennessee, not so much because we don't have as large a population. But the more populous states like California, Texas, Florida, Ohio, Illinois, Michigan, New York get a significant amount of water out of the surface waters. Um, Now, this is the percent of water that comes from surface water. A large percentage of Tennessee's water comes from surface water. You can see out in the west, particularly the southwest, not so much. It's a drier climate, so they don't get as great a proportion from surface water. They get more of it from groundwater. Here's a good example of a city that had to deal with some water issues. New York, large city, a lot of people, surrounded by salt water. They get their water from upstate New York. There are these watersheds that are largely undeveloped, forested watersheds that some reservoirs have been established there. So the water that runs off the land and through the land ends up in these reservoirs. And then a portion of that water is sent through an aqueduct, basically this large pipe, down to New York. It's a good system and supplies quality water. Now, there was pressure to develop some of this land in upstate New York around these watersheds and even in them. And so this would have compromised the quality of the water because you'd have more roads and parking lots and buildings and such like that. So that would have meant that New York would have had to spend money building water treatment plants to clean out this water more so than was needed otherwise. That was going to be very expensive, and an analysis showed that it was more cost effective to buy the land up in these watersheds or pay the landowners not to develop their land, to leave it largely undeveloped forest. So they basically let the landscape clean the water instead of having to build these water treatment plants that were going to be expensive to build and to maintain. Um, Now, in the United States, because we have, in other parts of the globe, because there are growing populations, and this does focus on the United States, the amount of water is fixed, and so you can see early on we were basically using more and more water. But then you reach a point at which you're sort of maxing out that water supply, and so the amount of water available, there's no more water there to use, but yet the population is increasing, and so this is going to require, as you can probably surmise, that we're going to have to become more efficient and use less water per person. Um, because around much of the globe, there is considerable water scarcity or even concern for water and the amount that's available and being able to supply quality water to a growing population. Um, so things like this parking lot can affect the hydrologic cycle because it is an impervious or impenetrable surface. So the water can't get into the ground as it would otherwise if this were a forest or a field. And so it quickly runs off in the storm drains and gets sent to the river quite rapidly. This can increase the likelihood of flooding in the river because the water is getting into the river faster, and it can also compromise water quality because of the things that get on the parking lot, that things that leak out of cars and such that can get washed into the river. So indeed, human developments can compromise water quality through runoff, those parking lots and roads, also the things we add to our lawns, the fertilizers and pesticides, and then in farmland as well, those kinds of things can can flow off the landscape. If you're raising livestock, the animal waste can be washed into the river and particularly increase E. coli and other bacteria that you don't really want in the river. These kinds of sources of pollution are known as non-point sources because they don't come from a clearly identifiable source, and they're spread out, whereas point sources are sources of pollution that come from a distinct point, a pipe that is draining into the river. Because of the Clean Water Act in the 1970s, these point sources have been significantly reduced because they're sort of the easiest to address. The non-point sources have been addressed somewhat, but they're harder to get a handle on, so they are still a significant problem. So here's a good non-point source, a feedlot, these confined animal feed operations, these large enclosed areas where you're raising lots of livestock in what could arguably be described as a relatively unnatural condition. As livestock like these, they're used to roaming around the landscape and migrating around, spreading their waste out, but now the waste get confined to one area, and so you have to deal with all these wastes, and you might use some of that manure to spread on fields, but if you're producing too much of it, which can often be the case, then you have to sort of store it. And you can see the pond off to the left here is a storage area for this waste. And when it rains and it washes through there, you're trying to contain that waste in the pond, but sometimes it can leak out if you get too much rain or the pond springs a leak or something, and that waste can get into the local waterways. Agriculture, we also put fertilizer, other kinds. That's in addition to animal manure, we put what you would call inorganic fertilizers, basically forms of nitrogen on the field. Particularly corn needs this, and a lot of corn is grown in the upper Midwest. If those fertilizers wash off into local waterways, it can result in eutrophication. You're over-fertilizing, too many nutrients in that lake, and the algae just go crazy, you might say. Case in point is the Mississippi River. We've got all this agricultural land, and it results in a lot of these nutrients being washed down into the Gulf of Mexico, and you get the formation of this dead zone, which is an area where those excess nutrients coming into the river causes algal blooms. The algae begin to die, they sink to the bottom, and as they decompose, the decomposing organisms use up the oxygen in water, and it becomes a, quote, dead zone because there's not enough oxygen in the water to support aquatic life. This is a problem in many areas of the globe. All right, I'll go ahead and stop here, and we'll pick up with the next video when we talk about some structures that can compromise or can alter aquatic systems.